So in the last video, we learned a little bit about radians and what they are, what they can be used for, but not really explicitly how to switch between them in degrees. So let's say we're given a degree, say we have a 90-degree angle. And what did we learn in the last video? Well, we learned that the full 360 degrees is just equal to 2 pi radians, because a radian has the arc length, right, of itself. One radian has the arc length of the radius. 5 radians would, have the arc length of 5 radiuses if we just keep adding up radiuses, like keep the circle going. Pi radians would have, well, you can guess half the circle, right? Because pi times r is half of the circumference. And so you can easily understand from there that 2 pi radians is just the angle to get 2 pi r, because you multiply how many radians you have times the radius to get your arc length, which is this green here. So from here we can actually derive an equation, can't we? Okay, so let's divide by 2 on both sides. Let's send that over here. So 180 is equal to pi radians. And so, radians, I'm just going to flip it over to the side, is equal to, wait, I forgot the degrees, 180 degrees over pi. And this does not exactly, this is 1 radian, 2 pi times 1 radian, 360 times 1 degree. So, basically, a radian is equal to 180 over pi degrees. We can count that all. And so to find another radian value, you just say x radians is equal to x times all that. So x radians is equal to 180 x over pi degrees. Just gonna write degrees. Just gonna put that in parentheses so that it's clear that I'm not writing some weird word like xrad or whatever. So great, that's all we need, right? Okay. So what is our well, what's a degree equal to? Let's do it the opposite way. So we can go back here and instead go that 1 degree, the 1 degree is equal to pi over 180 radians. And so x degrees, x times that is equal to x pi. Times pi over 180 radians, right? If we multiply each side by whatever, so if we have 90 degrees, 90 times 1, it's 90 times all of this. So immediately, let's solve for our 90. So we can use this equation right here. Let's circle that so it's clear. Okay, so 90 degrees, x, that's our x, here's our x, is equal to the same x, 90 times pi over 180 radians. And this is immediately obvious, right? 90 degrees is equal to pi over 2 radians. And that's a little obvious, right? If 2 pi radians is the full circle, and the 90 degrees has a fourth of that, and henceforth the arc length, then, yeah, that makes perfect sense. But what about something harder? Let's say... Ooh, what's a fun one? Let's say we have... What should this be? This should be... I'm going to say 120. Let's say 120 degrees. Okay. So if we have 120 degrees, we can write the equation again. Let's go to some new work. If we can clear any of this up. Let's just... You get the idea. I'll just rewrite the important bit. So we learned that 90 degrees is equal to pi over 2 radians. So it's 120. 120 degrees is our x is equal to 120 times pi over 180 radians. So what's that equal to? Well, we can easily just simplify this. 120 is equal to, right, 60 over 90. That's the first step, but then we can just reduce this to 2/3 pi radians. And that makes perfect sense. Okay, right, because that's 2/3 of our 180 degrees, and 180 degrees is pi radians, right? Because let's start a new color. If 360 degrees is 2 pi rad, then 180 is 1 pi rad is equal to pi radians. And you know, hence 90 is equal to, right, pi over 2. And we can reduce it even to 45. It's equal to pi over 4. Alright, so that's great. Now we know how to compute radians from degrees.